Hi everyone, this is Uday. My registration number is 14BEC0201. I am doing this semester COA subject in G1 slot. My faculty is Professor Dhanabal, and with his help, I am going to make this video. So in this video, I'm going to explain about Unit 4 in VIT syllabus of COA subject, COA Computer Architecture and Organization. So in this subject, the Unit 4 is Programmed Input Output, Interrupt Input Output Operations, and DMA, Direct Memory Access. So this chapter is particularly a theoretical chapter. You can expect a 10 marks question in every term and examination. So in this chapter, I'm going to explain you detail about what all the topics that we are going to cover. Okay, let's start it. So coming to the mode of transfer, you can see that data transfer is like from input output device is like from CPU to the input output devices. So it is of three types: program input output, interrupted initialized input output, and direct memory access. In this three way, the mode of transfer of information is transferred from one way to the other. Okay, so this is the external device block diagram. Like you observe this, here we can see the control logic, buffer and translator, the status of signals input, the control signal is coming in and the signal is moving out. Here all the data bits. From this I get idea about the external device of the block diagram. Okay, first of all, let's go to the input or output module function. It consists of the few functions. These are the few functions: control, timing, CPU communication, device communication, data buffering, and error detection. So coming to this, we can see like what is control and timing. Control and timing is like nothing but requirements to coordinate the flow of traffic between internal source and external device. Like it is just the time taken and how we want to control it. So the input output program has this follow the following steps. CPU checks the module device status, like it is connected or not, and the device status is returned to the CPU. And if the CPU, then if everything is fine, then CPU requests the data transform. Here we can see data transform. In this data transform, like input output module gets data. After the command is done, then we'll get the data transferred. Input module transfer the data to the CPU, and various outputs, like the various in the output depend on the modulate system. So let's deal with processor communication. In this processor communication command, this is the commands are used. That means commands that are accessed from the processor typically sent to the signals to the control bus. So these are the commands, then the data, then the status of reporting, like, and addressing recognition. Addressing recognition, I think that the address is given, and where the address of the what we need to collect is given, and from that memory we need to the address is given, and the address is to be recognized. And here the thing is, remember, is the address is like literally unique. And next coming to this is like device communication. Device communication is nothing but commands, status information, etc., and the data. So like this is the first we considered about process communication, and we went on through device communication. And this is the input output module diagram. You can see the resistors and input output logic, and the external device large, internal device large logic, the data structure control. Like this is the IO module, the entire thing. and this you can see here interface with the external device, and this is system bus. And I have a module decisions. Next is the next I have a module decisions. Hide or reveal the properties of the CPU. So you can see here support multiple and single device, control device functions only for CPU. Also OS decisions, like it is what like the decisions taken at that time to show the properties to CPU or not, or like based on device suppose. And in OS also some take something like, say for example, if we consider this Linux will treat everything as a file, like everything what can do it as a file, whether Windows will have some different thing. So these are the input output techniques: programmed, input driven, diagram runs. There are three techniques you can see here, and first we come with program input output techniques. The CPU has direct control over input output, like everything will be controlled by the string, like it's reading, writing and sensing commands and transferring, everything will be controlled by the CPU. The CPU waits here the wait CPU waits, so the ultimate thing happens is time waste. So let's go in detail about the program output detail. First, CPU request for this is like you can read here, like first it requests for operation, then if output for the operator, it's the output model sets some perform operation, then it sets some bits. After setting some bits, the CPU checks the status of bits periodically, and output model does not. Here see, we can learn that if the input model doesn't interrupt to the CPU, like if it couldn't, CPU waits for the or come back later. Input output commands, this is the commands. CPU issues the address here. And you can see the like in this input output commands, CPU gives the address. CPU issues and identifies model orders. That's what the address means. And CPU issues command as well. Control of telling module what to do, like and test, checks, read, write. These operations will perform by the CPU itself. And how will we assign address to the base? Under program data transfer, it is very like to memory access. From CPU viewpoint, you can see each device can unique identifier. Like a device will have unique identifier, and CPU commands contain that particular identifier or address. So that like the address is given to the devices. And next, input output mapping. Input output mapping is of two types: memory mapped mapping and isolated input output. Here first come to memory mapped input output. We can see like device and memory share as an address or space. Input looks like memory and read write, and no special commands for this. This is the only thing we need to consider is no special commands for reading input at once. But one thing is like for large section of memory, a lot separate commands were used. And compared to come to insulated mapping, separate address of space, not like single address like memory one. Separate address will be there, and need or output selection lines and special commands for input output. Like the commands here, some special commands will be available and not like a memory map thing. See, you can in the diagram you can observe what is the. Here you can see that what are the instructions given here and what are the instructions given here. This is isolated input output, and this is a memory mapped as input output. So in this both you can identify this. Okay. Now next go to what are the disadvantages in program input output. See, not why we are evaluating, because it has some disadvantages. Now here the disadvantage is you can see processor have to wait long time for input output module for concern the ready of either reception or transmission data. See, you can understand like the processor have to wait a long time, and performance of the system will be degraded, like will decreased. And also while waiting time, processor have to interrogate like the status is not available or not available or not. So this is a disadvantage. Overall disadvantage is slowing down the system. Now go to input driven input or interrupt driven input output out matching. This is the flow diagram. This is one of the important thing. See here, when we capture interrupts, CPU read the issues actually, then input output module will get the list per head list, and CPU does not work. Input module interrupts the CPU, and CPU requests data, and input output transfers. Here like CPU doesn't string this thing, so you can see the flowchart as well. Issue read and command to input output module, and read the status of input output module, check status if it is error condition or else ready. If ready, read the word from input output module, write 4 to the memory, done. Yes, it's gone, or no, again it will go to the first step. So this is a basic flowchart, and this flowchart is really important. It will be asked in term and examination. So simple interrupt processing. This is a simple interrupt processing. In this we will have two types: hardware and software. This is also an algo flowchart, and this is also important. So first thing is like the issue will be recorded, and the processors will execute current instructions. Finishes the person what is the instruction that is going on now will be finished by the processor, and processor signals sent a signal as an acknowledgement for the interrupt, and processes a PSW and PC to control on the stack, and processors loads the new PC value, and based on the interrupt like the value changes here. And now let's go to software turn. Save the remainder of the process state information, process again interrupt, and restore the process state information, and restore old PSW and PC. So this is the algorithm. This is the hardware part, and this is the software part. Based on this, the simple interrupt processing will happen. So now view what is from CPU viewpoint. From CPU viewpoint, see issue command. When the issue command is like in this one, when issue command it will do some other work and check the interrupt at the end of the instruction, not like the middle or something. At the end it will check the instruction. If interrupted, save context like through the registers and process the interrupt, and in processing information like fetching data and storing the data, and see operating system what is given by the operating system. That is the CPU point of view in this simple interrupt processing. So like what are the changes that happens, like if this happens here we can see like if we go here we can see changes the process on the PS process pushes the PS to control, and the process loads new value. Here we can see the change like here we can change in memory and registers for an interrupt. This is how it changes. You can observe previously it is a n-1 program counter. Now after the interrupt this total T minus control stack, and this part is T and this part is Y. Okay, we can see this like after processing. After if the interrupt happens, the program counter value will become Y plus L, not it from N plus L to its Y plus L. It will become program counter value will become like the value changes, as well as the stack pointer value from T to T minus N. So you can observe these changes due to the interrupt. Now let's go to the design issues, like how do you identify the module using design interrupt. Design issues also an important thing, and see here is the two questions for you guys, like how do you identify the module issuing the interrupt, and first question, and second question, how do you deal with the multiple interrupts. See, I think you got from the questions like when seeing from the second question is very interrupt, like if interrupt is harder being interrupted, like if interrupt is not single, multiple interrupt happen, is like design issues will occur, not suitable with simple algorithm. So for identifying interrupting module, for that we use this identifying interrupting module. So for this, different line for each module, PC, and limits the number of devices. Software port, CPU asks the module in turn, slow. This process is slow. So identifying interrupting module is the first process. You can see it's, and now it's come to DC chain or hardware port. Interrupt the acknowledgement sent to the chain, like hardware port in the sense the acknowledgement will send to the chain, and module is responsible for a vector on the bus, and CPU uses the vector to unfile the hardware routine. So this is what a daisy chain or a hardware port. Then bus master. Bus master is nothing but this module is there. This module should claim the bus before it can raise an interrupt. So, and also like here's the example. If a PCI and SCCA, these both are the examples for the bus masters. This is like identifying interrupting module, multiple interrupts. Multiple interrupts, like each line interrupts is each interrupt has a line priority and so on. Like high priority lines will interrupt and low priority lines will interrupt. If bus mastering, only current master can interrupt. So let's go with the multiple interrupts. In multiple interrupts, daisy chain. In daisy chain, the input output modules share a common input request line. Like if you see here is like bus terminator and bus terminator, and you can see high priority and this is the low priority interrupt. Both are like, this is middle priority, there isn't mentioned it, but when this is a high priority one, this is low priority one, but all these share the same line. And the acknowledge of line is daily changed through the modules. Like you can see, it is changed between the modules. So this is what the daisy chain. And bus attribution. The technique makes use of vectorized interrupts, that is bus attribution. See, in bus attribution, input output module must first gain the control of the bus before it can raise the interrupt on the request line. Thus, only one module can raise the line at a particular time. So, even though multiple happens, when the processor, only one module can interrupt it, like one after another formula, like in a queue we can say, we can consider this, and detect the interrupt and it responds the interrupt and acknowledges the line. The requesting module then places the vector on the data lines. So this is how bus attribution works. Example, and we can consider PC bus. Suppose we have 80 into 86 has one interrupt line, single interrupt request INTR and single interrupt acknowledge INTA. Right. So it has two lines. 8086 based system uses one A interrupt controller. See, and this controller have 8 interrupt lines. So now dealing with the 80 to 99 sequence of events will have what are equals 80 to 99 interrupt aspects interrupts, and it determines its priority, like which will become first, which will become next, and it will send the signals like rises INTR line, and CPU acknowledge puts the correct vector on the bus, like which one should first send, and CPU processes the interrupt. See, interrupt controller, he is external device. This is the external device. Suppose we have 63 external devices here, and each has some particular vector representation, and this is a slave interrupt controller interrupt, and his interrupt is given to the INTR signal. So the process previously which explained was clear mentioned in this diagram. Due to multiple interrupts if occur, this my 820 interrupt controller will direct the vector to an interrupt based on its priority, and it will be given. So 8269, this is programmable, and its priority scheme is defined by what are the controls we use will describe its priority. This is here we know the following 3 interrupt nodes will happen, that is like fully nested, rotating, and special mask. This fully nested is like from order of priority. Suppose from 0 to 7 IR, this is like IR 0 to IR 7. This is a fully nested based on the order of priority it works. And coming to the roasting, application numbers of interrupting device are equal priority. When it have equal priority, in this mode the device after being served receives the lowest priority in the group. So if suppose 2 buses, 2 or very two, like 120 to 707, both interrupts occur like at 366, then which have least priority in the group will be considered as the first. Then special marks. You can see here, it allows the processors to inhibit interrupts for certain devices. Only for certain devices is special. This is special. So this is Intel 82C55 programmable interface. This is the interface. You can see here data buses, power supplies, address, read, etc. And this is the pin. You can see this is the pin diagram. You can see here from 1 to 40 pins, and this is the pin in V out. Block, you can see here is the block diagram and is the pin diagram. So the 24 input output lines are programmable. Like you can see here, 24 lines are programmable PB. You can these lines are programmable by means of this 8-bit controller, and these 24 lines are divided into 8 bits. So 3 groups will be available. Each group function of a 8 input, each bit functions 8-bit input output port. In addition to CPU device variant, again divided into 4-bit groups. So CA and CB, which is used to conjugate the A-B out operations. So the 8-bit bidirectional data bus is DO and D7, like from DO through D7, D0, D1, D3, D1, D2, D3, D4, so on D7, used to transfer data from input output ports to and transfer information to the control list. Like these lines will transfer the information, and 2 lines specifically has 3 input output ports or control registers. Okay, and the reset line used to initialize the module, the reset line and chipset and read write. These are the commands, and this is write read available. Okay, the keyboard display interface of 82C55A. See, you can see here the keyboard display. So now we coming to the one of the main and most important topic, that is direct memory access. We shortly come as a DMA. DMA is like most used thing. For this problem, see, interpret driven and program input output requires active CPU interaction. Transfer rate is limited. CPU is tied up for managing input output transfer. For this problem, like overstraining of the CPU, the thing which is solution is DMA. DMA is direct memory access. Okay. DMA is like a additional module on bus. DMA controller takes the work from CPU for input output devices. See here, the DMA module must use the bus only when the processor does not need it. Like when a processor is using the bus, the DMA module has no right to control it, but when it doesn't read it, when it can be helped. The moves force the processor to suspend operation temporarily. This technique is called cyclic stealing. Cyclic stealing is like explained now. When the processor is using the bus, the DMA will be forced to give the bus to it. So this is the cyclic stealing. The typical DMA model diagram is like a data count, data register. So this is a typical diagram. Sorry. Data count and data register and address register and control logic. See, these 3 are the data lines, and is the address line with this, and this block diagram is also an important thing. So what is the DMA operations? CPU tells the DMA controller to read write and device address, starting address memory of the block data, and the amount of data that is to be transferred. This is the thing CPU tells it, and CPU carries on with another work. During this time, this DMA controller deals with this transfer, and DMA controller sends the interrupts when it finished. So here the workload on the CPU will be reduced. CPU bus signals for the DMA controller. Here is a DMA controller. This is a bus request and bus grant. This is what CPU do, and CPU will perform its own data, and this is all the buses and control CPU. But this will do the work and will send the interrupts to the CPU. So the direct memory access has, as I shown to you, is to have 2 bus grant and bus request. Bus request is like a signal from the DMA controller to CPU requesting a relinquish control of the bus. When the input is high, CPU stops executing the instruction and plays the address data and read and write lines at in high impedance. This is bus request, just asking for the bus. And bus grant is like giving the person like a signal from CPU to DMA controller. This is basically the DMA takes the control of the buses and memory transfer without intervention of the CPU. When the bus is run, DMA has entire control over the buses, and at the end of the transfer, the request line will be disabled and follows bus grant signal. So again, CPU has the power, will get retain its power on the buses once the bus grant signal is disabled and once bus grant request line is enabled. So here is a DMA controller. This is a block diagram, I can say it. Next, DMA controller is similar to an interface. See, it's not a special thing. It is similar to interface used to communicate with the input, and it's act as a mediator between CPU as well as this input-output device. Communication CPU is established data and control lines. It with the input-output device will act. It will communicate by using establishing DMA request and acknowledge. If bus grant is 0, CPU communicates with the DMA register through data bus and read and write the DMA registers. If bus grant is 1, then CPU relinquishes the bus and DMA can communicate directly with the memory. So this is how, based on the bus grant, it works. And DMA controller consists of address, word count, and control register. It consists of these 3 registers: address register, word count register, and control register. See, read register, write register, address bus, data bus, DMA acknowledge DMA request from input output device to DMA and DMA to CPU address select, and CPU to RAM. So at situations it will directly divert towards this rather than going to CPU and giving punishments bus grant is given. So how DMA controller works is like starting address memory block, whole data is available for read and write, where data is stored in write option. CPU, see, this all functions like CPU initializes the DMA and it starts sending the following information. So you can see here control, which like include like control to start DMA transfer, control to specify mode of transfer and such as read, write, word count, everything. This is what at the initialization stage CPU sends to the DMA. DMA now comes to the DMA transfer cyclic stealing. Cyclic stealing is the word familiar to you guys because I already explained what is cyclic stealing is. It's like the DMA will take control of the bus at a particular interval of time, like a particular cycle, transferred one word of data and not an interrupt. It transferred it, but the CPU doesn't switch context. CPU suspends just before access of bus, before an operand or data fetch the data wire. Slows down CPU, but not as much as the CPU going to transfer. This is what DMA transfer cyclic stealing. DMA and breakdown during the instruction cycle. So this is the processor cycle, and everything in this processor cycle: fetch the instruction, decode it, fetch operand, and extend instruction. This is the for everything it will have some breakpoint, and this is the entire instruction, and this is the interrupt breakpoint. You can see this is the interrupt breakpoint. And what is the DMA configurations? It is a single bus detached and DMA controller. Each transfer use bus twice, input to DMA and then DMA to memory. CPU is suspended twice. So this is the DMA configuration. You can see here single bus in single bus integrated DMA input output. Single bus integrated DMA controller may support a device greater than one, not a single device but also many devices, and each device can transfer use of bus from a DMA to memory and and can also CPU is a suspended ones. So this is what Intel 8237A DMA controller. This is what the commands we use and how it gonna work. This is like the theory stuff, but most probably you guys don't need to know this stuff. But knowing it will be helpful as a part of in exam. You can write it as a part of example purpose. So in this 8237 DMA uses system bus, this controller main memory. If you go through this, you can get know about what we are going to deal in this stuff. SQL, how it is gonna work. And now let's deal with the fiber. Why DMA is using buses like a particular ID processor uses bus DMA ideal known as this processing using bus DMA ideal is known as flyby DMA controller. Data does not process through and is not stored in a DMA chip. Like DMA chip is, I already explained you, it's like just act as a median, but it don't store anything. DMA only between input output and memory, and not between input output ports and two memory locations. So we can, it is not between, in a sense, like see, it can from input output device to memory, it can carry or transfer the information you through the permission of CPU, but not between from two memories, like from RAM to ROM or from cache memory to RAM memory. Can do memory to memory only through resistor, not with only this. This is we call flyby. So this topic is over. Now come with what to deal with these fat questions. So I already mentioned at the earlier, this topic, this chapter is mostly theoretical, like you don't get any problematic stuff, but in theoretical you'll get actually face a question and it's 10 marks. So here I took 6 papers, so I will show you guys what are the questions and what are the answers you can fetch. Everything I told, like everything answer for the question is already in the lecture, like in the PPT. If you follow the PPT, you can understand what happening. So this is the first question. Illustrates the operation of input output and simple interrupt processing with the flowchart, and prepare the performance with suitable examples. Like this is the question for this. I already, this is the first half of the PPT I can say you guys. So I'm gonna just show you like you need to what you need to write or till what input, like basic interrupt options. Input and options is flowchart, as well as this simple interrupt processing flowchart, and example using the diagram. So this is all you need to get. You need to get secure 10 marks, and you can see here this is a, every question is 10 marks and this is a 10 marks question. And so example also is important, so don't forget to go through the example which I already previously told you guys. So now going to the next chapter, you can see analyze the single bus detected DMA single bus to integrate the DMA input output configuration with neat diagram. So this is like nothing but to explain the DMA structure clearly. The question is given like that, so you need to write it. It's a theoretical question as well, and DMA is the, you can see this is an example for the previous question. So from here you need to start and write with the single bus stuff. CPU bus signals, DMA to input, DMA how DMA control work, DMA to input, DMA configurations, this stuff you need to write. But here they didn't ask you to write any example, so you don't need to write, but you need to do some diagrams. And next that is list of input output functions and compare the program input output, interrupt driven input output, DMA control input output operation with the detailed flowchart. This question is given for you guys for the 6 months. Input out, first you need to write input output model functions, then you need to write a short notes on the all these 3 input output functions. Like you need to compare, not but explaining them, but you need to compare. Just the difference is the least 6 marks you got. Rest in all other papers it's 10 marks, but here it is the least 6 marks. Now going to the next paper, you can see explain DMA control input output units. Everything they ask you is DMA, completely write DMA. Like the next half, like DMA is very, I already told you guys DMA is very important. So we already finished with the 4th paper. Now let's move to the 5th paper. We can see This is a signals operation with the DMA input output module and draw the DMA module diagram. This is also like a DMA, and you need to do the model diagram. See, this is like a very easy chapter. Only two topics like you can classify clearly, and the diagram is really important as it's not a problematic stuff. You need to draw the diagrams and move to the last paper. It's also, you got it here. Explain various input output modules of data transfer. Like you need to explain all the three data transfer functions, and this is also for time marks. So I previously told you guys, this is simply nothing but a theoretical chapter. So try to go through every slide in this particular PPT, and you can easily score 10 marks easily. Don't forget to write block diagrams and as well as the examples. So thank you everyone.